In terms of measuring sound energy, for the decibel scale is a human thing and it's logarithmic. And we're not going to focus on using that weird equation. We're just going to do it conceptually in terms of, remember, if you want to hear something 2 times louder, is it 2 times the sound energy? No, it's actually what? 10 times more, right? You trash your hearing 10 times more. But in terms of actually measuring the sound energy, that's called sound intensity, okay? And this is the equation, I equals P over 4 pi r squared. It looks all scary and complicated, but when you actually look at it and break it down, it's not too bad, okay? Intensity of sound energy is measured in watts per square meter. The next time you buy a set of headphones, or maybe you know that new iPod that just came out, woo, when you buy it, look on the packaging, and it actually tells you all the technical stuff about it. And in terms of the headphones, it'll tell you how many watts per square meter the headphones can pump out. Or if you buy a stereo, it's all about the watts, okay? So technically, the way you measure sound energy is in watts per square meter. Intensity, okay? Now in terms of what the human ear hears, that's loudness, that's measured in decibels. And you know how this morning we had that annoying fire drill? I actually took our decibel meter and held it up to the fire alarm there, the one in the hallway there. I actually got it to read when I was standing right next to it, 120 decibels, which if you remember is like the threshold of pain. I know some books and our online one says it's like 130 or 150, but really 120 decibels has scientifically been proven to show that you get long-term hearing damage. So the moral of the story is, don't stand by the fire alarm for a long period of time. That's why they make it so loud. However, okay, some of it is the wattage of your speaker, but then some of it is how far away you stand. Anybody recognize this 4 pi r squared? It's actually the equation for what? Not the area of a circle, right? That's pi r squared, but for the surface area of a sphere. So one way you can think of this is when you generate a sound wave, it's kind of like dropping a rock in a pond, and then the waters ripple out. This is like a 3D shock cone where the energy spreads out. So it's how many watts of energy are spreading out through every square meter of sound energy, okay? So this is the fifth little equation we want to add to our toolbox, okay? So if you put it right on your note card, or if you put it right in your notebook, you'll have it all ready to go there, okay? Sound intensity. So